At the end of this session, the learner will be familiar with the terminologies of testing of hypothesis as well as the procedure of carrying out tests of hypothesis. Today's topic is testing of hypothesis. Hypothesis is an assumption about the population. Population is generally tested with the help of its parameter, usually a mean, say mu. This mu can be equated to a constant and it is tested in different formats. Hypothesis can be tested as greater than or equal to a constant or mu less than or equal to a particular constant. If we are talking about two different populations, hypothesis can be comparison of the two means, say mu1 and mu2, mu1 greater than or equal to mu2 or mu1 less than or equal to mu2. Let us see a few definitions. Population is a set of all possible objects, an exhaustive set under study. Census is the study of this population. But it is practically not possible to have all the units of the population studied, hence a sample needs to be studied. Sample is a subset of the population. The necessity for testing arises because at times it is found that it is not possible or not practical to study every element of the population, or the population units get exhausted in testing. Example, electronic items or say blood testing. In such situations, sampling is the only option available. The study of this sample data for the population is based on two types called as statistical inference, covers estimation and testing of hypothesis. When the value of the parameter is not known at all, the parameter needs to be estimated with the help of the sample. But if there is some past data, some value known, believed to be true, the question of testing its validity arises, and that is where testing of hypothesis comes into picture. The next is parameter. It is a function of population values. For example, say mean of the population. Then comes statistic, which is a function of sample values. The same mean, if considered for the sample taken from the population, is called as a statistic. Now, the hypotheses that are tested are of two types. First one is the null hypothesis. The null hypothesis is a statement of no change, or it is a belief based on experience. It is called as H0 or H0. Now, as long as there is no apparent contradiction, no evidence available against the null hypothesis, it is always believed to be true. But the decision maker also requires to know some assumption which is an option if the null hypothesis is not true. Such an alternative is called as an alternative hypothesis, and this assumption has a burden of proof and it is a statement of change. It is also denoted by H1. Let us see how to formulate the hypothesis. Consider a null hypothesis which says that the mean IQ of people in a city is 105. If the information says that the mean IQ can either be 100 or 105, the alternative hypothesis that can be formulated will be the mean IQ is equal to 100. If the information available says that the mean IQ is never less than 105, the alternative hypothesis will be the mean IQ is greater than 105. If there is no information available about it, the alternative hypothesis will be the mean IQ is not 105, and generally it is written with a not equal to sign mathematically. Let us see one example of formulating the hypothesis. There is a spaceship and a crew member on the spaceship is found to be dead. Now, there is a scientific officer, Mr. S, who is supposed to test the statistical validity of the crew member and to decide the fate of the crew member, whether to vaporize the crew member or to revive him. This hypothesis can be set up with the help of statements of change or no change. Now, the status of the person originally is that the crew member is alive. Hence, the null hypothesis will be the crew member is alive, and the alternative hypothesis will be the crew member is dead or he is not alive, which is a statement of change in the status of the crew member. The problem of testing of hypothesis is actually a problem of deciding whether to reject or retain the null hypothesis H0 in the favor of the alternative hypothesis H1. The decision of rejecting or retaining this null hypothesis is taken on the basis of the sample which is selected from the population. But this decision cannot be always correct, or it may be incorrect as well. Now, what happens in nature, that is the state of nature, is not under the control of a decision maker. It is the actually existing state of the nature. The possible states of nature that exist are the crew member is alive, which means that the null hypothesis is true and the alternative hypothesis is false, or if the crew member is actually dead, the null hypothesis will be false and the alternative hypothesis is going to be true. Though the state of nature is not under the control of the decision maker, to take the decision is totally under the control of the decision maker. Occurrence of error or non-occurrence of error rather will happen due to the state of nature. Hence, the decisions that can be taken are reject the null hypothesis H0 if there is a sufficient evidence of death in this case, and retain the null hypothesis H0 if there is no sufficient evidence of death in the example of the crew member. Statistically speaking, if H0 is true and it is rejected, it means the crew member is alive, but there is a sufficient evidence of death. If H0 is true and it is retained, it means the crew member is alive and there is no sufficient evidence of death. The third possibility is H0 is not true and it is rejected, means that the crew member is dead and there is a sufficient evidence of death. And the fourth case is if H0 is not true and it is retained, the crew member is dead but there is no sufficient evidence of death. In simple English, if H0 is true and it is rejected, the decision is to vaporize a live person. If H0 is true and it is retained, the decision is to revive a live person. If H0 is not true and it is rejected, the decision is to vaporize a dead person. And if H0 is not true and it is retained, the decision is to revive a dead person. Hence, in general, we have rejecting H0 if H0 is true, giving rise to error, and retaining H0 when it is not true, also giving rise to error. These are called as type 1 error and type 2 error. Type 1 error is defined as error occurred when we reject H0 though it is true, and type 2 error occurs when we retain H0 though it is not true. Which one of the two types of errors is serious? To vaporize a live person or to revive a dead person? Obviously, type 1 error. Type 1 error is a very serious error. A good test will be a test which does not have either of the errors. In order to avoid the errors, if we always retain H0, we will avoid the probability of type 1 error, but the probability of type 2 error will increase. And in order to avoid type 2 error, if we always retain H0, type 1 error may occur. It is not possible to avoid both the errors simultaneously. In order to attain a balance between the two, probability of type 1 error has an upper bound put on it, and simultaneously probability of type 2 error is to be minimized in order to obtain a good test. Since the probability of type 1 error is more serious, that is rejecting H0 though it is true, an upper limit of alpha, a very small number tending towards 0 is put on probability of type 1 error. This upper limit on the probability of type 1 error is called as the level of significance, and in turn 1 minus alpha is called as the confidence level. Probability that no type 2 error occurs, that is 1 minus probability of type 2 error, is called as the power function or the power of the test. Setting up of a decision criterion involves partitioning of the possible test statistic into two subsets, one of which is attributed to the decision of rejecting H naught and the other to the decision of not rejecting or accepting H naught. For example, reject H naught if x is less than 50 and accept H naught if x is greater than or equal to 50. The partitioning of the number line into two parts, less than 50 and greater than or equal to 50. The region where the null hypothesis is rejected is called as the critical region. Hence, the procedure of testing of hypothesis generally is drawing a sample, calculating the test statistic, checking whether the point of the test statistic falls within the critical region or not. If yes, H naught is rejected. Now, this rejection region, that is decision of the critical region, in hypothesis testing can be in both sides of the curve, with the non-rejection region lying within these two rejection regions. A hypothesis test which has two rejection regions is called as a two-tailed test, and the one with a single rejection region is called as a one-tailed test. A test with a single rejection region can either be a left-tailed test or a right-tailed test, depending upon whether the rejection region lies in the left side of the curve or to the right side of the curve. And this tail of the test can be found out by the sign of the alternative hypothesis, the mathematical symbol used in the alternative hypothesis. For example, a two-tailed test will have a not equal to sign in the alternative hypothesis. The rejection region, that is the decision of the critical region in hypothesis testing, can occur in both the sides of the curve with the non-rejection region lying within these two rejection regions. Whenever there are two rejection regions, the hypothesis test is called as a two-tailed test, and the test with a single region is called as a one-tailed test. A single region test can either be a right-tailed test or a left-tailed test, depending upon where the rejection region lies on the curve. To decide whether a particular test is a one-tailed test or a two-tailed test, the mathematical sign of the alternative hypothesis is used. For example, for a two-tailed test, the mathematical sign of alternative hypothesis will be not equal to. Consider the example of a two-tailed test. The null hypothesis is H naught mu equal to 5000 against the alternative hypothesis mu not equal to 5000. When I say not equal to 5000, it can either be less than 5000 or greater than 5000. Hence, the critical region lies in both the tails of the test, with the non-critical region within the two critical regions. If the sample point of the test statistic falls in the critical region, either of the two on the left side or on the right side, hypothesis is rejected. For the null hypothesis H naught mu equal to 10, there are two alternatives. H1 can be less than 10, where the critical region lies in the left tail of the curve, and H1 mu greater than 10 implies the critical region will lie in the right tail of the curve. That is the region where the null hypothesis will be rejected and alternative hypothesis will be retained. The tail of the test depends upon the sign of the alternative hypothesis. That is, if there is a not equal to sign in the alternative hypothesis, we have a two-tailed test. If there is a less than sign in the alternative hypothesis, there is a left-tailed test, and if there is a greater than sign in the alternative hypothesis, it implies the test is a right-tailed test.